Hello and welcome to Tds Academy. So recently IIT Bombay has changed their syllabus a little bit to the each branches. So according to the new syllabus, we have made these charts in our best possible ways, and these charts basically give you an idea how to prepare your own charts, because ultimately you have to make your own charts of every subject, and after that you will get that confidence. So basically these charts will give you the ideas and perfect information after referring all the reference books. So let's begin with the first subject of GATE Mechanical 2021, thermodynamics. So second chart of thermodynamics basically includes remaining portion of second law of thermodynamics, then entropy, available energy, and thermodynamic relations. So let's start with the second law of thermodynamics. So here you can see that second law of thermodynamics, first law never fails, but it cannot fulfill the requirements like direction of process cycle, quality and energy, etc. So as you all know, first law is also known as energy conservation law, and second law is known as law of feasibility. Second law gives the information about the quality of energy. Now Joule's experiment demonstrated that high grade energy, which is work, can be completely converted into low grade energy, which is heat. So work of high grade energy, which is converted 100% into heat of low grade energy, but low grade energy of heat cannot be converted 100% into high grade energy of work. That is Joule's second law. Now, after the Kelvin-Planck statement, it is impossible to convert heat into work 100%. Efficiency is equal to work upon Q input, so efficiency cannot be 100%. Kelvin-Planck states that with single reservoir only. So that is the condition for Kelvin-Planck statements. After that, Clausius statement. It is impossible to construct a device which operates on a cycle and transferring heat from low temperature to high temperature. So for any cycle, it is not possible to operate on low to high temperature. These are some diagrams of that. After that, coming towards heat engine, refrigerator and heat pump. So first one is heat engine. You can see that here in diagram. In heat engine, Q in minus QR is equal to W. So efficiency of heat engine is equal to Q in minus QR upon Q in, and efficiency is also equal to 1 minus QR upon Q in, and that is equal to 1 minus T low upon T high for reversible process. After that, refrigerator. For refrigerator, COP of refrigerator is equal to desired effect upon. After that, refrigerator. For refrigerator, COP of refrigerator is equal to desired effect upon work supplied, or you can say that work input. So COP of R is also equal to QL upon QH minus QL, and COP of R is equal to TL upon TH minus TL for reversible only. But here note one point, that means coefficient of performance of refrigerator, which is equal to QL upon QH minus QL, is applicable for both reversible plus irreversible process, and in the terms of temperature, which is only applicable for the reversible processes. This is applicable for three engines: refrigerator and heat pump. Then heat pump, the desired effect is high temperature, so W in is equal to QH minus QL. COP of heat pump is equal to QH upon QH minus QL, and COP of heat pump is equal to TH upon TH minus TL. So once again, Q in the form of Q is only applicable for both the system, and in the form of temperature is applicable for only reversible process. After that, Carnot theorem. For various process or cycles, the efficiency of the reversible cycle is maximum in all the cycles. The efficiency of reversible depends on only temperature limit, not on working fluid or design of system. That is important point for the reversible cycles. Then efficiency of Carnot is equal to 1 minus TL upon TH for reversible, and QL upon QH is equal to TL upon TH for reversible only. Now integration dq by t less than or equal to 0 is the equation for second law of thermodynamics for cycles. After then, COP of heat pump is equal to 1 plus COP of R for same temperature T1 and T2. Now these two are some important case. Three cases are there. First case is both engines have same output, W1 is equal to W2, then Q1 minus Q2 is equal to Q2 minus Q3. After that, T2 is equal to T1 plus T3 by 2. For case 2, if W1 is equal to 2 times W2, then T2 is equal to T1 plus T3, 2 into T3 upon T3. This is the equation for finding T2 and W1 or W2 for the cases shown like in figure. After that, third case is efficiency of both the cycles are same, then T2 is equal to under root T1 minus T3. These three are some important notes points you can note down in your notebooks. After that, only for engines this equation can be applied. This equation is asked one time in grade examination, that total efficiency is equal to eta 1 plus eta 2 minus eta 1 into eta 2. Then T3 upon T1 is equal to T3 by T2 into T2 by T1. By coupling, efficiency is always increased. For example, eta total is equal to 0.3 plus 0.4 minus 0.3 into 0.4 is equal to 0.58. This is one example based upon this equation. Okay, now coming towards the entropy. Here in entropy there is one table that is most important from the entropy concept. Second law of thermodynamics says that integration del Q by T less than or equal to 0, and the entropy concept says that ds of universe greater than or equal to 0. That means ds of system plus ds of surrounding is always greater than or equal to 0. Now if del Q by T integration less than or equal to 0, then cycle is irreversible, and summation of surrounding plus system's entropy is always greater than 0. Most of the time irreversible process, and the change in temperature and entropy will increase. After then, del Q by T integration is equal to 0. That's why reversible cycle, and summation of system plus surrounding is equal to 0. And third one is integration del Q by T greater than or equal to 0, then cycle is not possible, or cycle or any process cannot be possible. For that, ds of system plus ds of surrounding less than or equal to 0. Here you can say that entropy of universe is always increased. Okay, then one more note is here, quality of energy is always decreased, but total entropy of an isolated system will always increase. Here entropy law is qualitative law. Entropy principle is quantitative statement of second law of thermodynamics, but the law is qualitative law. After then, thermodynamic Ts diagrams. Here for Q1 to 2 is reversible is equal to integration 1 to 2 into Tds at Carnot cycles. For Carnot cycle, two diagrams are given here. First one is PV diagram and second one is Ts diagram. Then W net for Carnot cycle is equal to Th minus TL into ds, which gives the area of cycle, and efficiency of Carnot cycle is equal to 1 minus TL upon Th. Now statistical views of entropy. Entropy is molecular disorderness. Disorderness means equal to uncertainty about the position of molecule at any state of time. Boltzmann defined the entropy as a thermodynamic probability. S is equal to K into L and W, where K is equal to 1.38 into 10 raised to minus 23, which is also known as Boltzmann constant. After that, for ideal gases, U is equal to CVDT, H is equal to CPDT, Du is equal to MCVDT, and DH is equal to MCVDT. And Cp minus U is equal to R, Cp greater than Cv, where R greater than 1. Or also you can say that gamma is equal to Cp by Cv. Okay, then Td is equal to CVDT, Cv is equal to T dLs by dt at constant volume, and Td is equal to Cp dt, Cp is equal to T dLs by dt at P. These both the equations were asked in the GATE examination in 2018 or 19. After that, entropy of gas greater than entropy of liquid greater than entropy of solid at same temperature only. If solid to liquid conversion, then entropy is increased. Now combine first and second law gives first law gives dq is equal to du plus dw, then Tds equal to du plus pdv, then Tds equal to dh minus vdp. These both the equations are valid for reversible and irreversible process both. Now slope of various process in Ts diagram. First one is constant temperature process, where Ts diagram represents that horizontal line, then slope is equal to 0. For reversible adiabatic process, slope is equal to infinity because theta is equal to 90 and tan 90 is equal to infinity. After that, V is equal to C means constant volume process, then Td is equal to CVdt, slope is equal to Cv into T del S by del T at constant volume. Then similarly for pressure is equal to constant, Tds equal to CVdt, Cp is equal to temperature into T ds by dt at constant pressure. So this is the diagram of T and S, which is already given in first chart. Now from this chart or this one diagram, always in 1 to 2 mark there is one question GATE examination from thermodynamic portion. So you have to remember this equation, and all the equations are very easy. So first one is entropy of any system. For system there are two parts, finite temperature body and reservoir. For finite temperature body, ideal gas and solid or liquid. If in the question there is given that for ideal gas like air or helium, then you have to use this equation of first one is S2 minus S1 is equal to m into Cv ln T2 by T1 minus R ln V2 by V1. Then second one is S2 minus S1 is equal to m into Cp ln T2 by T1 minus R into ln P2 by P1. Which is in the form of temperature and pressure. Then third one is S2 minus S1 is equal to m into Cp ln V2 by V1 plus Cv ln P2 by P1, which is in the form of P and V. For remembering this equation, it is very simple that in first two equation T2 by T1, which is directly proportional to volume and pressure, means T2 by T1 and V2 by V1 are same, but the sign between them is negative, and for the third one the sign is positive. Okay, after that for solid or liquid there is only one equation, S2 minus S1 is equal to mc ln Tf upon Ti. Now coming towards the reservoir or phase change problems are also considered in the problems of reservoir. In the reservoir two types are there. First one is source and second one is sink. So in the first one for source ds is equal to minus q by t, and for sink ds is equal to plus q by t. Here minus and plus signs indicates that minus is negative sign for heat supplied and positive sign for heat rejected. Here in the example you need not to be worried about the sign convention and directly put that equations. So after that, here one entropy concept is there. Then here entropy change in mixture of two liquids. Then the equation will be like, if there is any system given like this which is isolated and T1 greater than T2, then T final is equal to MC1 M1C1 T1 plus M2C2 T2 upon M1C1 plus M2C2 for mixture of two liquids and gases. Then ds of universe is equal to ds generation is equal to MC1 ln Tf by Ti plus M2C2 ln Tf by T2, that is also ds1 plus ds2. Then one special case is there, Tf is equal to T1 plus T2 by 2, where M1 is equal to M2 is equal to M and C1 is equal to C2 is equal to C for water. Then ds of universe is equal to ds generation is equal to MC ln Tf square upon T1 into T2. This equation can be helpful in the examination, from which you can directly find T1 and T2. And similarly for the entropy change in mixtures of two gases. For that, ds of universe is equal to ds of generation is equal to ds1 plus ds2 plus ds mixture. So Tf is equal to mct plus m2c2 t2 upon m1c1 plus m2c2. Then ds mixture is equal to minus r into n1 ln x1 plus n2 ln x2, where x1 and x2 is equal to n1 upon n1 plus n2 and n2 upon n1 plus n2 respectively. So you can take a screenshot of the screen also. After that, availability and exergy. So now in the availability for the two systems, first one is closed and second one is open system. So for the closed system, W max is equal to U1 minus U2 minus T0 into S1 minus S2, and W max is equal to M dot into U1 minus U2 minus T0 into S1 minus S2, which is in kilowatt. Now W useful is equal to phi1 minus phi2, and phi is equal to U minus T naught S plus P naught Vi. This is very important equation from the availability. And second, for availability in open system, so W max is equal to H1 minus H2 minus T0 into S1 minus S2, which is in kilojoule. A1 is equal to psi1 minus psi0, and psi is equal to H minus T naught S, which is equation of open system availability. And UA is equal to T naught into ds. In general, for cycles, UA represent unavailable energy. Then availability at a state A1 is equal to phi1 minus phi0, and A1 is equal to U0 minus T0 S1 plus P0 into S1 minus U2 minus T0 S plus P0 into S0. Okay, then I is equal to W max by W actual. So in these charts, when we have used that the symbol of that smiley, that means these tables are very important for the GATE examination. Here in the entropy topic also you can see that we have used the symbol of smiley, and here once again give Gauss-Taylor formula. Here once again Gauss-Taylor formula, which is also very important for the GATE examination. I naught is equal to T naught into ds of universe, and I is equal to Q in into T naught T1 minus T2 upon T1 T2, and third one is I is equal to Mr into T naught into del P upon P1. This is the equation of irreversibility. In general, I is equal to T naught into ds of universe. One example is also there. Then coming towards the exergy. Now third one is exergy. Exergy basically represent maximum amount of work that can be obtained from a system. Exergy divided in two types. First one is available energy, which is known as exergy for cycle, and if availability, then exergy for process. Here available energy is equal to W max is equal to Q in into 1 minus T naught upon TH, and Q in is equal to AU plus UA, means available plus unavailable energy. And area below T equal to C line represent T naught into ds. For available energy, conditions like cycle must be reversible and heat rejected at atmospheric temperature only. Then area below the constant temperature line gives the T naught into ds, means unavailable energy. Maximum work from engine. W max is equal to Q in into 1 minus T2 by T1. W max is equal to CV into T naught ln T naught upon T1 plus T1 minus T0. And for given diagram, if condition for maximum work is T is equal to under root T1 into T2, then W max is equal to Cp into under root T1 minus T2 square. So only these equations you have to remember. So here two examples are there, which is 2 times asked in the GATE examination. You can take a screenshot of that. Now moving towards which is thermodynamic relations. From this chapter there may be most important equations are Maxwell equations and the Other one is the Clausius-Clapeyron equation and the Tds equations. Three main equations are there, but all these equations you have to remember because there are from any topic there may be a direct one question from 1 mark. So first one is principle of exact differential. The principle of exact differential states that dz equal to m dx plus n dy and my at x is equal to nx at y. For exact differentiable term with x differentiate partially with respect to y keeping x constant. In same way for y. This is most important, which is also important for finding if its property or not. You have seen in the first chart also. So now second one is Maxwell Equation. Del T by del V at S is equal to minus del P by del S at V. And second one is del T by del P at S is equal to del V by del S at constant pressure. Then third equation is del V by del T at constant pressure is equal to minus del S by del P at constant temperature, and which is also known as Gibbs function. Then fourth one is Helmholtz function, which is equal to F is equal to U minus Ts. The equation for that is del P by del T at V is equal to del S by del V at T. Now Gibbs function is equal to G is equal to H minus T into S, and for Helmholtz function F is equal to U minus T into S. Gibbs function is basically useful for maximum availability for open system, and Helmholtz function is used for closed system availability. Then del P upon del T is equal to H of Fg upon RT square into LH, which is the Clausius-Clapeyron equation. Then fourth one is partial derivative theorem, which is also known as cyclic relation. The equation is like this: del P by del V at constant temperature into del V by del T at constant pressure into del T upon del P at constant volume is equal to minus 1, which is for thermodynamics only. And for maths you have also seen this equation like in the form of xyz. So, and if for xyz the function is same, then the multiplication of the three terms are 1. Now fifth one is Tds equation. This equation is very important. These equations were asked more than 2 times in the GATE examination. First one is Tds is equal to CVDT plus T into del P by del T at V into dV. Then Tds is equal to CPDT minus T into del V by del T at constant pressure into dP. First one is for V is equal to C, second one is equal to P is equal to C. And in the bracket you can remember this Tds equation in very simple way that for if first equation in the form of constant volume, then Cv is there, T into dB is there, but in the middle term del P by del T at constant volume. And similarly in the second one, all the terms in constant pressure, but the middle term is in constant volume and the sign is negative. Now sixth one is energy equation. Tds equal to du plus pdv, then du is equal to cvdt plus T into del P by del T minus P into dV for ideal gas, and u2 minus u1 is equal to cv T2 minus T1 minus A into 1 upon V2 minus 1 upon V1. That is equation for van der Waals gas equation. After that, volume expansivity, which is equal to beta, then beta is equal to 1 upon V into dV by dt into constant. Here volume expansivity, which is equal to beta, then beta is equal to 1 upon V into del V. Here volume expansivity, which is equal to beta, beta is equal to 1 upon V into del V upon del T at constant pressure. Second one is isothermal compressibility, KT. KT is equal to minus 1 upon V into del V upon del P at constant temperature. Then third one is isentropic compressibility, alpha. Alpha is equal to minus 1 upon V into del V upon del P at constant intervals. Fourth one is Cp minus Cv is equal to T into beta square into V upon KT. Then second law efficiency. COP of second law is equal to COP of actual upon COP of reversible. Then second law efficiency is equal to eta actual upon eta reversible. Second law efficiency of turbine is equal to W actual by W reversible, where for compressor second law efficiency is equal to W reversible upon W actual. Then irreversibility. I directly proportional to ds of universe. Then I is equal to T naught into ds of universe. Then Clapeyron equation is there. H minus HF is upon T set is equal to del P upon del T into Vg minus Vf. Then Clapeyron equation is there. H minus HF upon T set is equal to del P by del T at saturation into Vg minus Vf. Then last and final topic of this chart is Joule Theorem. There is one most important note for throttling, that after throttling process temperature may be increased, decreased or may be constant for isentropic expansion. Then the last and final topic of this chart is Joule-Thomson effect. Basically there is one diagram for Joule-Thomson effect, which is T versus S, means temperature versus entropy diagram. This diagram is for specific fuel only, and this diagram is not useful for all the fluids. This note you have to remember that. And mu is equal to del T upon del P at constant enthalpy. This is the equation of Joule-Thomson effect. It means that for positive value of coefficient of friction T1 less than Tm, for negative value T1 greater than Tm, and for zero value of mu T1 is equal to Tm. So here note for the Joule-Thomson effect that this diagram is not for all the fluids. Then second one is, if mu is equal to positive, then always cooling will represent it is not true. And the third one is maximum inversion temperature Tm after throttling process. If T1 greater than Tm, then heating is done. That is true for all the fluids, but we cannot say based on only mu. We have to find the Tm line from the diagram. So if T1 greater than Tm, then for all the fluids heating process is done, we can say that. Then for T1 less than Tm, cooling is done, and T1 is equal to Tm for constant system. One more point for the irreversibility, that actual work is always less than idealized work. So basically we have seen then in the first portion the second law of thermodynamics, which is remaining from the chart 1, then entropy concept, and then available energy, then last one is thermodynamic relations. So this is all about the second chart of the. If you think that this video is helpful to your other friends also who is preparing for the GATE examination 2021, please share this video as much as possible to them also, and do like and subscribe to the BS Academy. The next video, or we can say the next chart of the thermodynamics, will be coming soon as early as possible. For that video, do subscribe and press the bell icon to get the notification. Thank you so much.